Now that we are through with origin of mathematics, let us move to reasons why we study mathematics in modern times. Accounting still remains a valid reason why we study mathematics. But the way maths is studied today leaves much to be desired. It has gone beyond ordinary accounting. If accounting is just the reason why people should study mathematics, then many should not bother about it because once they learn mathematics to the point of enabling them to do their business and not be cheated in transactions, then they shouldn't bother about mathematics anymore. But today, we have very complicated mathematical operations. Why these mathematical operations that have become so complex? Many argue that they are worrisome and they shouldn't be at all. Do you agree with them? Anyway, don't answer yet until you hear me out. One reason why mathematics had to grow beyond accounting is that man discovered that every system that sustains his life behaves mathematically. He discovered that every system, whether it's a natural system or a man-made system that sustains his life or that supports his life, operates mathematically. Sunshine is mathematical. Photosynthesis going on in the plants, leading to production of sugars, is mathematical. The coming of the day and the night, that is, coming of light and darkness, occurs mathematically. Movement of the planets around the sun are mathematical. They are not disorderly. The growth of disease pathogens in our bodies is mathematical. A microbiologist would notice that microbes that cause diseases by binary fission multiply geometrically, causing very painful symptoms to the host of such microorganisms. It is those symptoms that show signs that there is a sickness. How these organisms multiply is mathematical, and so, if learned, the microbiologist could predict when the number of microorganisms in the body will reach a particular level that will lead to the death of the patient if not arrested. Therefore, mathematics is an important tool that helps predict what will happen in our natural world, because our natural world is filled with systems that support our life. Apart from sunshine, photosynthesis, movement of planets around the sun, multiplication of organisms in the body of the host, we have many other systems that support life. All of them are mathematical. I have just mentioned the natural systems that support life, all of which are mathematical. There are systems that are also man-made. Architectural designs like houses, roads, pedestrian crossings, just name them, engines of motor vehicles, and such like things. These things are man-made. But how was man able to organize these things into working systems? It is because man discovered that any system that is in existence, whether it is man that brought it into being or it is natural, has been found to be mathematical in nature. That was a wonderful discovery. So, with the mathematics that these systems have come to teach us, we can predict what these systems can do. Scientists derive much joy in being able to predict what will happen in a physical system, whether it is natural or man-made. So mathematics has come to be a tool of prediction, a tool of determining what is going to happen in a natural world. Man can use mathematics today to tell when eclipse will take place. Man can use mathematics to tell how much glucose, how much starch that will remain in the plant after it has used a part of the starch for itself before the emergence of sunlight the following day. A plant will first carry out photosynthesis throughout the day, produce starch, make use of a part of the starch to keep itself alive until the following day when sun comes out. By the time the sun comes out, it has made use of a portion of the starch it made during the day. The amount of starch it makes use of before the next day comes is not something that is obtained by disorder. It is purely mathematical. Everything we see around us is mathematical. Therefore, the summary is that today, if you see people trying hard to learn mathematics, it is not simply because they want to be good in accounting, even though all of us need it. There is nobody in this modern life that does not need accounting. That one is settled. So accounting is the overall reason why people engage in mathematics. But those that engage in more complicated mathematics do so because of added reasons. These things include science and technology, as well as engineering. Therefore, whenever you see a modern man studying mathematics, it is either he is doing it for accounting purposes, for the purpose of science, for the purpose of engineering. You yourself, each time you solve mathematics, do you know that each answer you get means something? If you don't know the reason you study each topic in mathematics, then most likely you will find it difficult. Why do you rejoice? Why do you rejoice when you get the correct answer to a question in mathematics? It is not simply because you got the answer. It is because of a real life problem, a real life challenge you have surmounted, you have solved, you have handled by means of numbers. So, on a daily basis, we solve mathematics, but most of the time, we don't know why we're solving them. Most of you ask, for all the time I have been solving mathematics, I have been told to find x, to find y. What does x mean? What does y mean? This platform is not explaining to you what x and y mean. In the course of time, you know what they mean. But know it that every answer you get in mathematics has a problem it has solved. It is because people don't know this fact that maths is boring to them. How do you feel when you are facing a challenge? You have headache. You don't know how to go around that challenge, but eventually you solve it. You'll be so happy. So if maths is the tool in your hands to solve your problems, use it. Because eventually you will see a reason why the mathematics is applied in the first place. Therefore, maths is for accounting, it's for science, it's for engineering. Now, let's move on to the next objective, and that is the major aspects of mathematics. Mathematics has branches, it has aspects. History teaches us that mathematics had to evolve into different branches. That is, people developed systems that needed mathematics in different areas of life. So we have about three major aspects of mathematics. These aspects of mathematics are given based on the application of mathematics. Don't forget that mathematics is science of numbers. But since mathematics has been found to be useful in handling and predicting characters of natural systems, mathematics has become a tool in our hand to make our lives better. Most of what we know about our environment, we know because we tested and we discovered. If we are told what we know about our environment without investigating them, and those things are true, we'll be said to be learning by revelation, the original system that could have led to knowledge, bountiful knowledge, without stress. But today, unfortunately, or sometimes fortunately, because we still have this thing we call opportunity to learn, we still know that we are fortunate that we are not left in the dark. So we are fortunate that we can still learn about an environment. But it's unfortunate that we learn with a more difficult approach, that is scientific method. It should have been by revelation. You know something because you are told. But today we know because we discovered. Discovery is difficult. But since we have a means, we are grateful. Now, it is not every time you see mathematics that we do it for the sake of science of numbers. We might be doing mathematics as a tool for solving real life problems coming from different sections or different natural systems. So based on application of mathematics, we have three main aspects of mathematics. They are: one, arithmetic; two, algebra; then three, geometry. Let's briefly explain what each of them is. First, arithmetic. Arithmetic has been mentioned earlier. It is still a branch of mathematics, despite the fact that the name is now hiding under it. In entire mathematics, we have numbers that count things. If I say, for instance, 5 tubers of yam, As you can see on the screen, if you write 5 tubers of yam, the 5 that counts the tubers is known, is a known figure. And what it is counting, what the 5 is counting, is also a known item. That which counts is called a counter, and that which is counted is called the countee. Let's take it that way. So the yam in this case is the countee, and the 5 is the counter. A type of mathematics in which both the counter of items and the items being counted are known and are definite is called arithmetic. In the expression 5 tubers, 5 is known and the tubers are also known. This is why this is an example of expression found in arithmetic. What about algebra? Algebra is an extended type of arithmetic, advanced arithmetic. If we say advanced, it might mean that it is better. No, it's not better than arithmetic. So let's not use the expression advanced. It is derived from arithmetic. How? Let's find out. When what is counting is known, but what it is counting is not known, then the branch of mathematics we have entered at that point is called algebra. Take for instance, if we write 5y, as you see on the screen, 5y. Obviously, we know what 5 stands for, but we don't know what the y stands for. Definitely, y stands for something, but it's not known to us. Y is the countee, 5 is the counter. The counter is known, the countee is not known. Compare it with arithmetic, where we have both the counter and the countee known. In this case, that is 5y. The counter is known, the countee is not known. A type of mathematics in which the counter is known but the countee is not known is called algebra. This is where letters of alphabets from different languages of the world are employed to represent the unknown. That y, as we see on the screen, could represent an item or another number. Y could represent yam, but we don't know, except we are told, or except that y is determined by calculation. It is either we are told what y is, so we carry out substitution, or we solve an equation and get the value of y. But until then, we don't know what y is. So the type of mathematics dealing with the unknown countee, not the unknown counter, although sometimes both the counter and the countee are not known, but at least one of them must be missing. So the mathematics that features letters of alphabets that represent the unknown is called algebra. What about geometry? Geometry is derived from both arithmetic and algebra. It is pure application of mathematics. It is not math itself. We should call it an application of mathematics. It is better called an application instead of branch of mathematics. In geometry, we don't learn how numbers behave. We apply the behavior of numbers in solving structural problems. Geometry is application of mathematics either in arithmetic form or algebraic form to solving problems associated with angles and dimensions. The houses we live in, the roads we walk on, the vehicles we drive, every system that has a structure that benefits us in one way or the other was constructed either naturally or artificially. Either way, measurements were taken, calculations were made to determine the shape that will best suit the purpose for which that thing was built. Therefore, application of mathematics in determining the accuracy of shapes using dimensions of the shapes and the angles of the shapes is what we refer to as geometry. We better refer to it as an application of mathematics, not a branch. But loosely, so far we have seen that we have three branches or three main aspects of mathematics. They are, again, arithmetic, algebra, and geometry. This platform will not delve deep into each of them. In the course of the higher and more challenging topics, we take time to develop each of them and see the real need for each of these three aspects of mathematics. Now, let's talk about the next item in our list of objectives. That is the major forms of numbers. A form of number is a style of writing a number. Over time, different persons in different professions have found different styles of writing numbers as preferred styles. Each style is peculiar to a profession, but one thing is clear. All persons, all professionals that make use of numbers want to achieve one thing. And what's that? Each person wants to express a number in the least stressful form. That means that in writing a number, there should be convenience. It is desire for convenience that leads to evolution of what you have known all the while into other forms of numbers that have come to be.